So, good day to each and everyone, and we are the group 11, and we're going to discuss about the nano world. So, welcome to the world of extremely minute objects. So, for our objectives, we have here to distinguish nanotechnology from nanoscience, identify the applications and benefits of nanotechnology, discuss the issue and concerns of using nanotechnology, explain social and ethical considerations of nanotechnology. So, what is nano? So, nano referred to Greek prefix meaning dwarf and refers to the realm of objects and phenomena exist at the nanometer scale. It is the world of extremely minute objects. So when we say nano, more is a nickname to something that is real small. It's about the world that's so tiny and we can see it with our naked eyes and also impossible to imagine. This could be anything from tiny particles that make up the materials around us to the component of cell in our bodies. And we have here mentioned about nanometer scale. So nanometer scale is a way of measuring things that are incredibly small. So 1 nanometer scale is 1 billionth of a meter. So nanometer scale are about objects and phenomena na gamay kaayo and measured in nanometers. O para makita nato ning mga tiny particles, kailangan nato magamit og special tools to be discussed later. So for quick review, we have here matter. Matter is defined as a substance that occupies space and has mass. So matter is anything has space and takes space. It's all the stuff that makes up our world. So for example is kana imong bangko na gilingkuran and your air you're breathing, food we eat, and of course even ourselves are all made up of matter. So, nasa different forms of state like solid, liquids, and gases. So, kung makita nato ni closely, matter is made up of tiny particles called atoms. And atoms combines in different ways to make up everything we see and touch. So next is volume. Volume is the amount of space taken up or occupied by an object. So for example is kung naa kay box, ang volume ani is pila ka object or stuff ang mosulod ana na box. So next is mass. Mass is the amount of matter that something else is made of. So mass is mao ni siyang measure of amount of matter sa object. And the standard unit of mass in International System of Units is kilogram. But dili siya the same sa weight. Kaya ang weight is measure of force exerted of an object due to gravity. While mass is amount of water in an object. So kung bisag asa ka sa universe, ang imong mass kay dili na siya mausab, pero ang weight is mausab. So now let's proceed to the nanoscience versus nanotechnology. So first is nanoscience. So nanoscience is a discipline of understanding extremely small things using commonly accepted experimental and theoretical techniques. Encompasses various fields such as physics, chemistry, and engineering. And the technology that utilize it in practical applications like devices kay tinatawag siyang nanotechnology. So, nanoscience is about studying and understanding sa mga extremely small things or things at nanometer scale. Ang mga scientists kay nagagamit og variety of methods para masabtan ang study sa nanoscale world. And kini na method kay mao ni siya ang experimental, theoretical, or using mathematical models and computer simulations for prediction kung unsa may behave kung unsa mag-behave ang nanoscale systems. And it also combines knowledge and techniques from several different areas of study and moto kaning physics, chemistry, biology, and engineering. So sa physics, ginasadihan nila ang behavior para masabtan og mapredict kung unsa ang nanoscale materials mag-act. While sa chemistry, it am interested in how atoms and molecules interact to form larger structures. And at nanoscale, this can lead to new and interesting properties in the field of chemistry. While in biology is ginagamit nila ang nanoscience para isadihan ang process and to develop new tools of biotechnology. While engineers use nanoscience para mag-create og mga new materials and as well as devices. So while nanoscience provide as a knowledge at nanoscale world, ang nanotechnology takes that knowledge and use it para mag-create a real world of applications. So the development of nanoscience can be traced to the time of the Greeks and Democritus in the 5th century BC, when scientists considered the question of whether matter is continuous and thus infinitely divisible into smaller pieces or composed of small, indivisible, and indestructible particles, which scientists now call atoms. So, the Greek philosopher Democritus, who lived in 5th century BC, siya ang isa sa mga first na nagpropose na everything in universe is made up of tiny, indivisible particles. Gitawag ni siyang particles as atomos, kung asa gikan ang atom na word na atong ginagamit today. And Democritus wondered kung ang matter ba is continuous, meaning it could be divided into smaller pieces or it made up of small indivisible particles. And this becomes a fundamental question about the nature of the universe. And sa karon, we already know na ang matter is really indeed made up of atoms, and also discovered na ang atoms themselves can divided into even smaller particles, and mao ni ang protons, neutrons, and electrons. So, naka-develop sa tag tools that allow us to manipulate and study aning mga particles. And mo ni siya ang field of nanoscience. So, ang development sa nanoscience can be traced back to these early philosophical questions about the nature of matter. So now let's proceed to the nanotechnology. And nanotechnology refers to the manipulation of matter on an atomic or subatomic scale. And it is the study of what happens when things get very, very small, only a few atoms in size. It refers to the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometer. It employs the study and application of exceptionally small things in material science, engineering, physics, biology, and chemistry. So, nanotechnology is the science and engineering of working with extremely tiny particles called nanoparticles. And these particles can be measured in nanometers, which is maotong 1 billion of meter as 1 nanometer, which I mentioned earlier. So, mao ni ang naga-manipulates or control aning mga particles para mag-create to new materials, devices, and structures with unique properties and functionalities. So furthermore, ang nanotechnology po daw is used in various fields such as in materials science and engineering. And it used to develop stronger, lighter materials. And when we talk about stronger, lighter materials, that mana siya ang enhanced strength and durability while being in lightweight at the same time. Example, ani ka ng metals that it's used for strength but it is so heavy. So, while ang light materials parehas aning plastic may not have the same level of strength. So, with the help of nanotechnology, naka-create ang scientist kung asa makombine nila or ma-enhance ang strength while may reduce ang weight. And it really helps to industries and today. So, when it comes to physics and chemistry, ang nanotechnology kan ginagamit para to understand the fundamental properties of matters, such as studying atoms, molecules, and how they interact and combine to form various substances. In biology, and nanotechnology helps the study of cells and DNA and develop new medical treatments. So, nanotechnology is a very diverse field that is having bigger and bigger impacts on the world. It has applications in medicine, cars, spacecrafts, food, electronics, and material science. And it refers broadly to a field of applied science and technology whose unifying theme is the control of matter on the molecular level in scales smaller than 1 micrometer, normally 1 to 100 nanometers, and the fabrication of devices within that size range. So, nanotechnology daw is all about mo siya working with incredibly small particles and to create amazing new things. And naano siya big impact sa atong kinabuhi or sa atong kalibutan. Mura ni siya natay superpower para makabuild and para makontrol nato ang mga tiny scale. And so na siya application sa medicine, like to deliver drugs directly to specific cells sa atong body, and it making treatment more effective. So when it comes to cars and spacecraft, it used to create lighter and stronger materials that can improve fuel efficiency and also safety. So when it comes to food industry, nanotechnology used to improve food safety, enhance flavor, and increase absorption of nutrients. And when it comes to electronics, nanotechnology helps to make electronic devices smaller, faster, and energy efficient. In material science, it used to develop new materials with enhanced properties.
Benefits of nanotechnology. Number 1 is it improves performance, enables the development of nanomaterials and devices with enhanced properties leading to improved performance in various applications. So in this case, it is one of the major benefits of nanotechnology is indeed improving performance. By harnessing the power of nanoscale materials and devices, we can enhance their properties and make them perform even better than before. It's like giving them a supercharged boost. So the next one is miniaturization. Nanoscale components allow for the miniaturization of devices, leading to smaller and more portable electronic and medical services. So So this refers to the process of making things smaller and more compact with nanotechnology. We can manipulate materials and devices at the nanoscale, allowing us to create incredibly tiny components. This has led to the development of smaller, more powerful electronic devices such as smartphones and computers. It is like a lot of power into a tiny package. So miniaturization has also enabled advancements in medical devices, allowing for less invasive procedures and more precise treatments. So the next one is, or the third one is, energy efficiency. Contributes to the development of energy efficient technologies such as more efficient solar cells and energy storage devices. So it is one of the another significant benefit of nanotechnology. By this, it utilizing nanoscale materials and devices, we can create energy efficient solutions across various industries. For example, in electronics, nanotechnology enables the development of more efficient transistors and processors, reducing power consumption and extending battery life. In the field of renewable energy, nanomaterials can enhance solar cells' efficiency, allowing them to convert sunlight into electricity more effectively. So, additionally, nanotechnology plays a role in improving energy storage systems, making them more efficient and capable of storing larger amounts of energy. So, nanotechnology contribute to a greener and more sustainable future by optimizing energy usage. So the fourth one is environmental sustainability. Offer a solution for environmental remediation and pollution control, contributing to a more sustainable future. So this is the crucial aspect of our future, and nanotechnology can play a significant role in achieving it by leveraging nanoscale materials and processes. We can develop more sustainable solutions across various industries. For example, in the field of water purification, nanotechnology offers innovative methods to remove contaminants and pollutants, ensuring cleaner and safer water supplies. Nanomaterials can also be used to create more efficient and lightweight batteries for electric vehicles, reducing a carbon emission, which is one of the major problems that we have right now, and promoting clean transportation. Additionally, nanotechnology enables the development of eco-friendly construction materials with enhanced insulation properties, reducing energy consumption in buildings. So, the last one is improved healthcare. Enables targeted drug delivery, early diseases detection, and personalized medicine, leading to improved healthcare outcomes. So in this case, nanotechnology enables significant advancement in the field of healthcare by utilizing nanomaterials and nanodevices. We can enhance various aspects of healthcare, including diagnosis, treatment, and prevention. For example, nanoscale drug delivery systems allow for precise targeting of medications, maximizing their effectiveness. Additionally, also, nanosensors enable early detection of diseases, facilitating prompt intervention. So, nanotechnology opens up so many possibilities for medical innovation and plays a critical role in improving human health and well-being. So, kaniwala na case na. Unlike before na ang So, unlike before, di ba, na ang mortality rate kay na lang sa mga gap, age gap between 30, 40, around that age. Tapos as our technology na naga-update or evolve, especially nanotechnology, kinang makaano jud ta na diba ma-witness jud nato na kanang ato ang oldies, the old generation can enjoy their life longer. They suffer more longer. They can enjoy more longer if ang uban gani kay makaabot pag 100 plus. Tapos because yun na sa sa technology, nanotechnology. So yeah, as the technology evolves, ang atuang mortality rate po kay ga-expound. I think sa Philippines kay around hapit na mag 80 years old ang mortality, which is good though. Kay sa Japan baya kay na around sa mga 82, 83 mangguto, which is mo lang pinaka-old na country kay dagan kay centenarian. So yeah, this is a good news.
So, now let's proceed to how small is nanometer. So, unsa man gid kagamay ang nanometer? So, may video na i-present and let's observe it.
Nano World. What is nano? Nano is a unit for measuring the extremely small. Nano size is measured in nanometers, which is 1/1000th of a meter. How much is a billion? For example, let's look at an emperor penguin. Let's zoom in on the emperor penguin's skin. This tick is about 1/1000th of a meter. The bacterium attached to the tick is about 1/1,000,000th of a meter. And there is the bacterium's DNA. The DNA's radius is about 1/1,000,000th of a meter. That is 1 nanometer. DNA is made up of many atoms, and atoms make up all matter. This is the nano world. This nearly invisible world can be viewed with an atomic force microscope.
So, based sa video, ang nano size is measured in nanometers and 1 nanometer is equal to 1/1000th of meter. So, unsa ni kagamay ang bilyon? So, based sa example, makita nato na ang penguin is equal to 1 meter. And pag zoom in sa skin sa penguin na ay something kuto yata to siya. Kuto na ang size is about 1 in 1,000 of a meter. And pag zoom pa jud, nakita dito ang bacterium sa kuto na ang size is about 1/1,000,000 of a meter. And the bacterium DNA radius is 1/1,000,000 of a meter. Og mao to ang 1 nanometer scale. So kung makita niyo sa video, kung mao to siya ang explanation kung unsa ka gamay ang nanometer. So how to view nanomaterials? So, scientists use special types of microscopes to view nanomaterials. So, first is electron microscope. It utilizes a particle beam of electrons to light up a specimen and develop a well-magnified image. And isa ni siya sa mga powerful scientific instrument to magnify and analyze smaller objects, and it provides a greater detail and clarity. Next is the scanning tunneling microscope. It enables scientists to view and manipulate nanoscale particles, atoms, and small molecules. So it has the ability to visualize atom and molecules on close-up level and use a sharp metallic to scan the surface of conductive sample, also primarily used for studying conductive materials. Ang ikatulo is scanning probe microscopy. It is the branch of microscopy that scans the material with a physical probe to provide images of the surfaces. So makita ninyo sa picture, no? Mao ni siya. And it also an instrument for imaging surfaces at the atomic level, created in 1981 in conjunction with the development of scanning tunneling microscope. So ang broad term sa words microscopy and technique including STM and EFM, and maka-measure ni siya of different properties like electrical conductivity, magnetic fields, or mechanical properties. So next is the atomic force microscopy, or the AFM. It is a type of scanning probe microscopy with demonstrated resolution of fraction of nanometer. A mechanical probe is used to feel or touch surface in order to collect the data. So it can be operated in various environments including air, liquid, and also vacuum. So now let's proceed to the nano manufacturing. So it refers to skilled up, reliable, and cost-effective manufacturing of nanoscale materials, structures, devices, and systems. It leads to the development of new products and improved materials, composed of two fundamental approaches. Mao ni siya ang bottom-up fabrication and top-down fabrication. So, ang bottom-up fabrication, it manufactures products by building them up from atomic and molecular scale components, or it is smaller and smaller particles and that are joined together to create a bigger figure. So it is a chemical process, and it do not require any external agent to assemble them because they chemically assemble themselves by recognizing the molecules of their own type. So, and ang top-down, kaya mo siya ang trims down large pieces of materials into nanoscale. So, it is a physical process. Ang large-scale object is progressive, reduced in dimensions. Ang kini siya na method is time-consuming and relatively costly. So, based sa picture na makita na to nga ang bottom up is ang process niya kay from gamay hantod mo ipon na pod siya sa other particles hantod magkadako, while ang top down kay from bigger gamay siya hantod nagagamay na pod siya. So based sa pictures. So now let's proceed to the approaches to assembly of nanomaterials. So first is the chemical vapor deposition. Muna siya ang process used to make materials from a series of chemical reactions. And molecular beam epitaxy, it is a process used to deposit a thin films. And next is atomic layer epitaxy. It is a process where layers comprised of single atom thickness are deposited into surfaces. Next is self-assembly. It is a set mo siyang process kung asa ang different elements is brought together without interventions to form a structure. Next is the deep pen nanolithography or the DPN. Ang kani siya na process kay it is resembles the functions of an ink pen, and it involves paggamit of chemically saturated microscopic tip which is used to write on surfaces. And a lithograph that hits the above 100 degrees Celsius is capable of fabricating metal electrodes more effectively than a conventional electron beam. Next is the nanoimprint lithography. So it is a nanoscale stamping process where features are imprinted into surface. And roll-to-roll processing. It is a process where ultra-thin strips of metal and plastic are imprinted with nanoscale devices of a rapid frequency.
Issues and concern about nanotechnology. So, nanotechnology is a term encompassing nanoscale science, engineering, and technology. So, diba, it is a fascinating field as it focuses on understanding, controlling, and exploiting the unique properties of matter that can emerge at scale of 1 to 100 nanometers. So, this field holds a great potential for advancement in various industries. It is also a key issue before Congress regarding nanotechnology is how best to protect us humans, our health rather, safety, and the environment as nanoscale materials and products are researched, developed, manufactured, used, and discarded. While the rapidly emerging field of nanotechnology, it is believed by many to offer significant economic and societal benefits. Some research results have raised concerns about the potential adverse environmental, health, and safety EHS implications of nanoscale materials. So, some have described nanotechnology as a two-edged sword. So, bale, napod siya pros and napod siya cons. So, di man dyan na maiwasan na. On the other hand, some are concerned that nanoscale particles may enter and accumulate in vital organs. So diba kita, especially na some of us kay ignorante. And then mas lamang pa jud ang negative perspective kaysa positive. So yeah. So di ba kanang nanoscale kay gagmay siya, so it may nanoscale particles kay gagmay jud siya, like more siya dust, something close to dust may enter and accumulate in vital organs such as the lungs and brains, potentially causing harm or death to us humans and animals as well. And that the diffusion of nanoscale particles in the environment might harm ecosystems. On the other hand, some believe that nanotechnology has the potential to deliver important EHS benefits, such as reducing energy consumption, pollution, and greenhouse gas emissions, remediating environmental damage, curing, managing, or preventing disease. So, and offering new safety-enhancing materials that are stronger, self-repairing, and able to adapt to provide protection. So, nga nang special kay nanotechnology o nga na po siya issue? So, what's so special about nanotechnology and why it is on issue now? Karon, chemists have dealt with naturally occurring nanoparticles all along. Think molecules or viruses. Toxicologists have dealt with nanoparticles that are the result of modern human life, such as carbon particles in combustion engine exhaust without being aware of it. Tire manufacturers use nanotechnology, carbon black, to provide the performance of tire as early as the 1920s. So, dugi-dugi na siya, no? Medieval artists used gold nanoparticles to achieve the bright red color in church windows. Gold particles in nanometer size are red, not golden. You might even say that we are surrounded by it. Makaingon jud ka ana. It is made of nanostructures. Atoms and molecules are nanoscale objects after all. So what is all the fuss about it? And where do these issues come from all of a sudden? So take note that an important aspect of the nanoscale is that the smaller a nanoparticle gets, the larger its relative surface area becomes. So the smaller the nanoparticle, mas dako ang surface area. Its electronic structure changes dramatically to kanang dili education mag-change. Both effects lead to greatly improved catalytic activity but can also lead to aggressive chemical reaction. So, what do we mean by catalytic? So, more chemical reaction siya caused by the presence of a catalyst. A catalyst is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. So, ang perfect example ani kay ang charcoal, ang uling. So, there are 5 typology of the issues, which is the social context issue, contested moral issues, technoculture issues, form of life issues, transformational issues. So, the social context issues arise from the interaction of nanotechnologies with problematic features of the social or institutional context into which they are emerging. So, the social context surrounding nanotechnology is definitely an important issue to consider. As with any new technology, there are various social factors that come into play. Some concerns, most common concerning ma-encounter nato, some include the potential impact of job markets, ethical considerations, and the distribution of benefits and risk. It's crucial to have open discussions and involve diverse stakeholders to ensure that the development and implementation of nanotechnology are done in a way that benefits society as a whole. Tinang maka-benefit ito. Kaya mama dyan ang goal, diba, pag magbuhat kag technology. So yeah. And by addressing these social issues, we can strive for a responsible and inclusive advancement in nanotechnology. So the next one is contested moral issues arise from nanotechnology interaction with or instantation, I don't know how to pronounce this or how to read this, of morally controversial practices or activities. Example, those that a substantial number of citizens believe should be prohibited. So like any other technological advancement on nanotechnology, it can give rise to contested moral issues. These arise when nanotechnology intersects with and enables practices that are morally controversial and are believed by a significant number of people to be prohibited. More on like, I don't know pa, pero murag bad mo kan siya. Kaya ma-apply rin siya sa mga close-minded na mga tao. Or kanang na ay religion na bawal ni sila ha, mag something ana. And so it is important to recognize the different individuals. So, diba? We should respect naman kay di man ta pare-pareho perspective. Or it may have varying perspective on what should be considered morally acceptable or prohibited in relation to nanotechnology. These debates often revolve around concerns such as privacy, environmental impact, health and safety, and ethical implications. Open and respectful dialogue is crucial in navigating these complex moral issues and finding common ground. So the next one is technoculture issues arise from problematic aspect of the role of technology within the societal systems and structures from which and into which nanotechnologies are emerging. So these refer to the problems that arise from the role of technology within societal systems and structure. With nanotechnology, these issues become particularly relevant as it emerges into society. This can include concern about the impact of nanotechnology on social dynamics, power structures, and cultural values. Same rin siya sa contested moral issues. Pero more on like technological focus na dun siya. It is important to critically examine how nanotechnologies are integrated into our society and to address any problematic aspect that may arise. By understanding and addressing these technoculture issues, we can ensure that the development and implementation of nanotechnology align with our societal values and aspirations. So the next one is form of life issues. Form of life issues arise from the nanotechnology's impact on societal standards, practice, and institution. Example, family structures, social networks, and life trajectories. Social norms are often predicated on facts about or particular understanding of the human situation, i.e. the human person, our relationship with each other, and our relationship to the natural environment. Emerging nanotechnologies are likely to alter that situation. So these issues stem from the impact of nanotechnology, from the nanotechnology itself, kay humurog whole life naman ni nato. And nanotechnology has the potential to influence various aspects of our lives, including, family structure, social network, and life trajectories. This is because social norms are often based on our understanding of the human situation, including our relationship with others and the natural environment. As nanotechnologies continue to emerge, they may bring out changes that alter this situation. So, the more na naga-update, the more na like naga-change jud ang maga-bring jud changes. So, pag naman jud new update, like example ani kay katong from keypad to touchscreen. So, di ba, naman yung changes na nahitabo. Which is, okay naman. As long as basta ang importante kay na-adapt nimo. So, it is crucial for us to carefully consider and navigate these changes, diba, to ensure that they align with our values and promote the well-being of individuals and society as a whole. So, diba, dili lang puro man cons ang ato ang absorb aning technology, specifically nanotechnology, nabud siya pros jud. So yeah, kanang balance lang. So the last one about the typology of the issues is that transformational issues. Transformational issues arise from nanotechnology's potential, particularly in combination with other emerging technologies such as biotechnology, information technology, computer science, cognitive science, and robotics, to transform aspects of the human situation and not merely, as with life issues, modify some parameters. So, in this issue, this might be accomplished by significantly altering the kind of creatures that we are, reconstituting our relationship to the natural environment, creating self-aware and autonomous artificial intelligence, diba? Artifactual persons, or developing robust alternative environments, virtual worlds that are as rich, immersed, and socially complex as the physical world. So, diba? Kani ba lang prior to COVID pa lang gani ga-exist na ni. Tapos during atong COVID mas ni ano jud siya, mas ni murag na-explode good, like murag bisikat jud in a good way, kay diba matadto ka ng lockdown, so wala jud social interaction na mahitabo kay bawal, and mauro jud to ang way para maka-social interact ta sa lain pod. So na jud siya pros jud. Ang nakakon ng ani kay instead na mag-focus ta sa outside visual or internet world, mas mas nalulung. Even until now, kaya murag na-adapt na dito na to na lifestyle. Thanks COVID. So, the typology of concerns. Environmental impact is the number one. The release of nanoparticles into the environment could have unintended consequences, such as pollution or harm to ecosystem. So, the environmental impact of nanotechnology is a significant concern. So, concern na lang tanan. When nanoparticles are released into the environment, there is a potential for unintended consequences such as pollution or harm to ecosystem. So, di mo dyan mawasan. Like, even gani ka nang magkuan ta, like, kita as human, kita medyo salat. Di ba kita as human na kuan kanang habang ga-produce taga hatag po ta og kuan kanang environmental impact negatively. Kita may gabuhat pagyapon ani, so yeah. These nanoparticles can interact with various components of the environment, including soil, water, and living organisms. So, loy jud sila. Kita ra po jud ani kayong mabalik ra man sa to ang consequences. It is important for researchers and policymakers to carefully assess and mitigate these potential risks through responsible development and implementation of nanotechnology. By considering the environmental impact and taking necessary precautions, we can strive to minimize any negative consequences and ensure a sustainable and safe approach to nanotechnology. So the second one is health risk. There are concerns about the potential health effects of exposure to nanoparticle, including respiratory issues and toxicity. So, Health risks associated with exposure to nanoparticles are indeed a concern. These are worries about potential respiratory issues and toxicity when individuals come into contact with these tiny particles. Tapos, diba, di yung na to usually makita kayo gumay sila unless mag-microscope ta. So, diba, kuan ba siya ka ng hazardous siya ka ng toxic siya. It is important for researchers and regulatory bodies to carefully study and understand the health effects of nanoparticles to ensure the safety of individuals who may be exposed to them. By addressing these concerns and implementing appropriate safety measures, we can strive to protect the well-being of both workers and the general public in relation to nanotechnology. So the third one is ethical considerations. Nanotechnology raises ethical questions such as privacy, concerns with nanosensors, and the responsible use of nanomaterials. So it raises ethical questions that need to be addressed. One of these concerns is privacy. So, diba? Kung tanaw ka sa kanang documentary about China, diba? Maano man din mo pag China kay communist rather. So kanang murag mas labaw pa jud ang sa ilang mas napadjay power ang gobyerno sila, tas rampant kay ang sila kanang mga CCTV kanang murag wala na jud sila privacy. Even kanang pinakagamay nimo na information sa mga kagalingon napud ang gobyerno. So yeah, kanang murag kulong ka sa mismong country nimo jud. As nanotechnology advances, the use of nanosensors for various purposes such as monitoring and data collection, may raise privacy concern. It is essential to establish ethical guidelines and regulation to ensure the responsible use of nanosensors and protect individuals' privacy rights. So another ethical consideration is the responsible use of nanomaterials. Nanomaterials have unique properties that can be beneficial in various applications. However, it is crucial to consider their potential environmental impact, health risks, and disposal methods. By promoting responsible practice in the production, use, and disposal of nanomaterials, we can minimize potential harm and ensure the ethical use of nanotechnology. So by addressing this concern, it is vital to harness the potential benefits of nanotechnology while safeguarding privacy and promoting responsible practices. So the fourth one is regulatory challenges. Developing effective regulations to ensure the safe and responsible use of nanotechnology is a complex task. So murag di siya dali. So developing effective regulations to ensure the safe and responsible use of nanotechnology is indeed a complex task. The unique properties and potential risks associated with nanomaterials require careful consideration and thorough evaluation. One of the challenges in regulating nanotechnology is the need to strike a balance between promoting innovation and ensuring safety. It is crucial to foster advancements in nanotechnology while implementing regulations that mitigate potential risks to human health and the environment. Additionally, the rapid pace of technological advancement poses a challenge for regulatory bodies. Keeping up with the evolving field of nanotechnology and its applications requires continuous monitoring, research, and adaptation of regulatory frameworks. So by acknowledging these challenges and working collaboratively, regularly, bodies can strive to develop effective regulations that ensure the safe and responsible use of nanotechnology, benefiting society as a whole. So the last one is public perception. Lack of awareness and understanding about nanotechnology can lead to public skepticism or fear. So di ba pag lack of awareness jud kay mas dominant jud ang kahadlok. Kay wala pa man tay knowledge about na nabutang. So yeah, mas dominant jud ang kahadlok. So, the lack of awareness and understanding about nanotechnology can indeed lead to public skepticism or fear. When people are unfamiliar with a technology, especially one as complex as nanotechnology, it is natural for concerns and misconceptions to arise. So to address this, it is crucial to promote public education and engagement regarding nanotechnology. So importante jud ang i-educate and ma-engage ka na nabutang. So by providing accessible and accurate information, we can help bridge the knowledge gap and dispel any misconceptions. This can be done through various means such as public lectures, educational campaigns, and interactive exhibits. So, take note that one of the most pressing challenges in nanotechnology is the need to enhance our understanding of materials and their properties at the nanoscale, since materials at the nanoscale exhibit different behaviors compared to their bulk form. There is a concern regarding the potential toxicity of certain nanoparticles. Some doctors express worry that nanoparticles, due to their tiny size, could easily cross the blood-brain barrier, which protects the brain from harmful chemicals in the bloodstream. This concern becomes especially important if we intend to use nanoparticles to coat various surfaces, ranging from clothing to highways. It is crucial to ensure that these nanoparticles are safe and won't pose any harm to our health. By addressing these concerns and conducting thorough research on the safety and potential risks associated with nanoparticles, we can strive to develop nanotechnology applications that are both innovative and safe for widespread use. Thank you.
So, hi everyone, I am Levity Flores and I am also one of the reporter. So the topic assigned to me is all about social and ethical considerations of nanotechnology. So let's begin. Nanotechnology will have very broad application across all fields of engineering. So it will be an amplifier of the social effects of other technologies based on the material unity of nature at the nanoscale and on technology integration. There is an especially great potential for it to combine with three other powerful trends, such as biotechnology, information technology, and cognitive science. So these powerful trends highlights such existing issues like in biotechnology we have the treatment of disabled, in information technology we have communication breakdowns, in cognitive science we have economic stagnation and threats to national security. So it is essential for nanotechnology stakeholders to strive to achieve four social objectives. First is developing a strong understanding of local and global forces and issues that affect people and societies. So it is it is important to develop a strong understanding of mga local and global issues na atong naranasan today. Now, if it how what are its cause and effect sa every individual or in the society itself. So, second is like guiding local and global societies to appropriate uses of technology. So, it is important to have a guidelines or a set of guidelines when using or how we are going to appropriately use technologies. It's because naman yung mga risk factors na kailangan nato i-consider. So, it is important to be wise and using technologies. Third is alerting societies to technological risks and failures. So, it is also important to be alert and we are aware, we are educated sa mga technological risks and failures, because it might be have a kanang kumbaga dako siya o na siya somehow an effect, though it has na siya mga benefits, but napod siya mga disadvantages na kailangan nato i-consider. Fourth is developing informed and ethical personal decision making and leadership to solve problems in a technological world. So it is also important to develop ethical personal decision making and leadership to solve a certain problem or issues in a technological manner. Next is nanotechnology itself may possibly raise distinctive ethical and social issues in the future. Thus, it will be important to integrate social and ethical studies into nanotechnology developments from their very beginning. So, can you try is like, kailangan na to, or it is important to make, to raise a distinctive ethical and social issues in the future. Kailangan na to magbuhat o research, kani siya. Kumbaga, we need to consider, we need to make a research in order for us to aware, educate, or di ba, in a technology, di mo dyan na siya magdugay. It is possible man dyan na magka-malfunction ang isa ka technology. So, it is important to make a research for us to kumbaga, we need to consider also what might happen or what would be the outcome in the future. So, kailangan na ito mag-integrate o mga social and ethical studies into nanotechnology and how we are going to develop a certain nanotechnology. At least, individual or in the societies would know or at least na sila idea of about a certain research na gibuhat, like social, scientific, and economic research. So it can help also not just societies but manufacturers and governments to make a policy to kumbaga when it comes to deploying a new technology, diba? So it also helps research on how we are going to maximize its benefits for the use of every individual. Next, so lastly, the significance of nanotechnology depends largely on how its development relates to wider trends going on in the world. So well-established social scientific explanations for mga unethical behavior such as learning, strain, control, and subculture theories. Kana siya is like makatabang siya for societies for the understanding mga possible future cases in nanotechnology industries. So that ends my report. So I hope you learned something and thank you. So that ends our report and I hope you learned something